use variation parameters to solve the given system. So to use parameter method, here's a step you need to do. First, you need to find homogeneous solution and then find the non-homogeneous solution. After that, you add them together, which gives you your final answer. Okay, so here are the steps, and it's not a detailed step, but I will walk you through it step by step for a specific problem. Okay, so let's put this aside. So for this one, first find homogeneous solution. Okay, so first you need to have a minus lambda I. What is a? Let's call this matrix a. Okay, and then take this matrix subtracted with lambda, that gives you a minus lambda I. Okay, because I'm familiar with it, so that's why I didn't write it down. But for some of you who did not see it, so I have to write it down. All right, so it's down here now. Find the determinant of a minus lambda I, which gives you this one. Set it equal to 0. Solve for lambda, you will get complex eigenvalues, which is 1 plus and minus I. So for lambda equals 1 plus I, plug it into a minus lambda I. It gives you this matrix augmented with 0. If I choose K2, let me take this back. So from the second equation, I know that K1 is equal to IK2. If I choose K2 then K1 is I, and my vector K is I1. Then my homogeneous solution is equal to C1 times the real part of vector K, which is 0, 1, times cosine 1t, y cosine 1t, but not other t. The 1 comes from the imaginary part of lambda, okay? And multiply by e to the 1t, y 1t again. The 1 comes from the real part of lambda, okay? Subtract imaginary part of vector k, which is 1, 0. Multiply by e to the t times psi t, okay? So because you have a complex eigenvalue, once you know the first solution, your second solution is similar to the first one, except few changes here. So plus C2 times your second solution, and your second solution is similar to the first solution, except you have opposite side here. E to the t cosine t and e to the t sine t stay the same. So for these vectors, you switch their position. That gives you second answers, okay? Second answer. All right, so this is your homogeneous solution. And then if you multiply this together and then add or subtract them together, it gives you this matrix. Similarly to this one, it will give you this matrix. Okay, so here's the simplified answer. Now it's time to find non-homogeneous part. So similarly, like a minus lambda I, you need to have a matrix which I obtained from homogeneous part, and I call it function phi of t. Okay, so basically you exclude C1 and C2, then put the rest into this matrix. First, after you're doing that, you find the determinant of phi of t. That gives you negative e to the 2t. Then you need to find its inverse. That is equal to 1 over determinant times this vector, this matrix. And for upward diagonal line, you are going to multiply by negative 1. For downward diagonal line, you switch their positions, bring this up, bring this down, okay? It gives you this matrix. Then you need to find u prime of t, which is equal to inverse phi of t times f of t. What is f of t? F of t is what left over when you multiply by vector x, which is this one. Okay, so here's the whole thing is your f of t. Okay, multiply them together, it gives you this matrix, and simplify it, it gives you 0, 1. Okay, so negative plus positive 0. Here's the identity of trigonometry. Sine square plus cosine square equals 1. And before we move on, let me say this. So for this one, when you multiply matrices together, do not swap their position, do not swap their order, because if you do that, it will give you a different answer, and it's not the same as this one, because multiply matrices together is not the same as multiply variables or numbers. For example, a times b is not the same as b times a for matrices, okay? So keep in mind that. So when I have this matrix, I iterate this one to obtain u of t. So iterate this one, it gives me 0t, very simple. Now it's time to find your non-homogeneous part, which is equal to phi of t times u of t. Again, do not swap the order. It has to be in this order, okay? Otherwise you will get an incorrect answer. Okay, multiply these together, it gives you this matrix, and your final answer is equal to homogeneous part plus non-homogeneous part, which is this one. Okay, so let me put it down so that you can see both homogeneous and non-homogeneous parts. Okay, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.